Hi, my name is Seowon, and I'll be presenting on turpentine availability and possible uses from industrial applications. And this is a topic I studied and researched over the summer with Dr. Chauhan. So first off, what is turpentine? It is a byproduct of the craft pulping process in pine that isolates turpentine, rosin, and fatty acids. And it is extracted via distillation from pine, and the turpentine oil is composed of terpene, and these hydrocarbons include mainly alpha-pinene and beta-pinene, and also some lesser amounts of camphene, 3-carene, and limonene. Through different processes, terpenes from resin have various industrial uses, and that includes agrochemical, fragrances, nutraceuticals, pharmaceuticals, and biofuels. And specifically in this presentation and my paper, I focused on application on agrochemical and biofuels, and this will be discussed later. So image on the left shows the craft pulping process. So wood goes in, which in this case would be the pine. And going through these processes, the byproduct of the pulping process is turpentine. And images on the right shows the chemical structures of alpha-pinene seen over here and beta-pinene. So the questions addressed in the paper was, first, what is the current global availability of turpentine? And the estimated maximum availability of turpentine. And secondly, how deep is the literature? This means how credible was the source and how recent and not outdated source was the information given. And then two more sub questions were examined, which was what would be the amount of product assuming certain percentage conversion of turpentine, and B, if the product is to displace an existing fossil fuel, chemical, and material, what percentage does the hypothetical product displace? So to answer the first question, the estimated availability of terpene was 3 million metric tons, which comes from multiple sources. However, one source from 2004 said approximately 300,000 metric tons in 1995. However, I had to examine more papers going further so that I can improve on that outdated number. So that is the 3 million metric tons. However, although the 1995 one was outdated, we can say that there was a projected increasing availability over time of soybeans. So first application I looked at was dimerization. In this context, it was for jet fuels, like biofuel jet fuels. So in this experiment, as you can see this table over here, they examined the different catalysts for different types of catalysts in certain different temperatures over time. And here they listed the dimer yield from the experiment and the products they got at the end. So the highest yield achieved was Nafion, as you can see over here, at 100 degrees Celsius for 2 hours with a yield of 83%. So looking at these numbers, if we convert all turpentine, which is 3 million metric tons in the world with a yield rate of 83%, which is from the experiment, the final prediction of global turpentine production would be 2.5 million metric tons. And comparatively, it has been estimated that the world's total refinery production in 2004 was about 4,000 million metric tons. So aviation fuel accounts for 6.3% of the total oil consumed in the world. And so because of this, this would not be a reasonable way to contribute all turpentine in the world, because the total yielded amount at the end was only 10%, which does not account for that many. So secondly, I looked at another application, which is from agriculture, and this is about urea, and this is widely used as a fertilizer in agriculture to provide plants with nitrogen to promote growth, because it is necessary in photosynthesis. So I examined a 2018 study and they compared the nitrogen loss of different coated urea fertilizers in the soil that changed by moisture content, and that compared to normal urea. So RCU was prepared in the experiment using 4% crude pine oil resin dissolved in commercial petrol. So again, looking at these numbers, urea production yearly reached 200 million metric tons per year in 2018, and nearly 90% of urea was consumed as fertilizers. So based on this, we can conclude that 180 million metric tons of urea was used as fertilizers annually. How the 4% is for coating the pine is necessary to coat the pine resin. So it would be concluded as 7.2 million metric tons is needed to coat the urea. So knowing that, again, 3 million metric tons of turpentine is available globally and annually, using all the availability would account for 41.7% total needed. Because we can treat this amount with entire turpentine availability, it would be reasonable, comparatively more than the dimerization application, to be considered contributing the resources as urea fertilizers. So to conclude, all I've discussed, as turpentine can be more useful and valuable resources for various industries than how it is now, further evaluation and development should be considered to use them effectively. So these are the list of references I had for all the data and information, and these are the image resources. And that was my research topic. And to talk about my overall experience at Talaria, I would say I really enjoyed working here with Talaria over the summer because how much I was able to learn about scientific research and learning about my specific topic that we chose to examine. And it was really nice to observe the how much I've accomplished up till now through a meeting with Dr. Trujano, my mentor, over weekly meetings, and how she guided me very kindly how to do the scientific research and how to look at different literature and types of literature. And the overall experience was great, and I'm really thankful that I was able to further my scientific abilities through this research and continue my passion with STEM. So that concludes my presentation, and thank you so much for listening.